Good morning everyone. So, we'll discuss first the answer writing for the mains part, then we'll cover our syllabus part. So, one question that was asked was how geomorphic agent like wind, glaciers, rivers determines the landscape of Earth. Still not correct, no? So I'll give you tomorrow. So how geomorphic agent like wind, glacier, rivers determine landscape of Earth? This was one of the questions that was given in the test. Now, what you have to keep in mind here is, if you have to write this in 250 words, because it is talking about everything, wind, river, glaciers, you have to make your answer more concise. If you are not making your answer concise, you will keep on writing these particular part. Fine. So what you have to start with, that wind, rivers and glaciers are potent geomorphic agent. Wind, glaciers and rivers are potent geomorphic agent that reshapes the landscape of Earth and creates new landforms. So this is how you need to start your answer. Wind, rivers and glaciers are potent geomorphic agent that reshapes the landscape of Earth and create new landforms. Clear? How they create new landforms? Through process of erosion, deposition, transportation, etc. This is how you need to start your introduction. So introduction should be what? Introduction should be regarding wind, glacier and rivers, that these are the potent geomorphic agent that reshapes the landscape of Earth and create new landforms through process of what? Through process of transportation, deposition as well as erosion. Fine. Then, as we discussed, you have to explain the river, wind and glacier landforms. You have to explain river, wind and glacier landforms. So, in the main body part, you start with the rivers, or you can make a heading that landforms created by the river. You can make heading, and then you can write that rivers are what? Rivers are creating new landforms through process of lateral and vertical corrosion and deposition. Remember, we discussed corrosion is the process which is dominating when corrosion is the processes which is dominating in the rivers. So rivers are creating new landform through process of lateral and vertical corrosion. We discussed in the higher stage, when the upper course river have a vertical corrosion, in the middle course river has a which type of corrosion? Lateral or horizontal corrosion, and lastly in the lower course we have a concept of deposition. So this is what you have to write, that rivers are creating new landform through process of lateral, vertical and horizontal corrosion, and then you can make that the different landforms created by rivers are, then write down upper course. And what are the landforms created in upper course? Then middle course. What are the landforms created in the middle course? And then lower course. So this much you have to write regarding nothing but rivers. Okay, so river landforms are created through what? It is created through process of lateral vertical collision and deposition. So in upper course, what river are forming? You can mention about gorges, you can mention about waterfalls. In middle course, what rivers are creating? We discussed river cliff, slip of slope, meandering fashion, meanders. And in the lower course, you can write about the deltas. You can write about estuaries, Oxbow Lake. So these are the landforms created in what? Created in nothing but lower course. If possible, make one diagram indicating meandering part, or indicating what? Indicating the Oxbow Lake. Okay, you just make a diagram indicating that. That much will be sufficient for the landform created by the rivers. Fine. Then second part, you have to quickly move on to the second part, which is a landform created by glaciers. Landforms created by glaciers. Here you have to write the glaciers are found in polar region and in high mountainous region mountain regions, and they create landforms through process of plucking. Remember, we discussed which process is dominating? Plucking and abrasion. So you can mention about these points, that it creates landform through the process of what? Through process of plucking and abrasion. Fine. Now here you can mention about what? Here you can mention about landforms in highland region and landforms in lowland region. So in lowland regions, what you are getting is moraines, you are getting drumlins, esker, you are getting glacial till. Here you can mention about what? The Bergschend, Lake, Lake. Then also you can mention about Hanging Valley, U-shaped valley. These are sufficient to explain the glacier part. Then landform created by wind. Landform created by wind. Then you have to move on to wind part. Fine. You have to write that wind landforms are created more in desert region. Where winds have a dominant flow, to process of deflation and abrasion. So highlight these points: plucking. You can highlight this in your answer: plucking and abrasion, lateral, collateral. You can highlight those points, okay? To which these landforms are something that are created. Clear? Then you can write about what are the landforms created by what? Created by wind. So we discussed the mushroom rock. You can mention mushroom rock. You can mention about Yardang. You can mention about Jugan, Mesas and Buttes. You can mention about these landforms, and on here you can mention about depositional landforms. So here you write erosional landforms, and here you can write depositional landforms. So depositional landforms, what you are finding? Depositional landforms, what you are finding? We are finding dunes. Last class we discussed dunes are divided into barkens and seaf. And then you can mention about loess. So these are the landforms created by the winds. These are the landforms created by the wind. You can mention about depositional landforms and erosional landforms of the wind. Clear? So this is all about what? This is all about, okay, what are, which one? Seaf, S-E-I-F, seaf. But loess, L-O-E-S-S, loess. Right? So those are the landforms that are created by whom? Those are the landforms that are created by the wind. Finally, you can conclude. Okay. Conclusion, you can write together these geomorphic agent determines Earth's topographic, soil formations, sediments deposition, and biodiversity distributions. So these are the points you can write in the conclusion, that together these landforms, that is river, wind and glaciers, determine topography. Topography means what are the highland features and what are the lowland features that are there. They can determine what? They can determine soil formation, they can determine sediments deposit, as well as biodiversity distribution. So all these are something that are determined by who? Determined by the geomorphic agent.
This much is enough for
This much is enough. This can be more than 250 words. If you count the number of words, it will be more than 250 or around 200 words. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So around 25 words your introduction is there. Then you have written landforms created by rivers, landforms created by wind, landforms created by the glaciers, and finally, okay, you have talked about conclusion. So this is the how you have to concise your answers in certain part. See, once you read geography, what will happen? Knowledge will not become a problem. Okay, you will have a knowledge to write, but what to write and how to concise your answer becomes a problem in the examination, because you have to write, you have to cover many dimensions in the questions, and also your answers are within a defined words, so that you can attempt all your questions. Fine? Any doubt regarding this one? Next question. The second question that was given was with regard to explain the distribution of volcanoes around the world, and how distribution of earthquake coincide with distribution of volcanoes. Fine. So these were the two things. Explain the distribution of volcanoes around the world, and how distribution of volcanoes coincide with how the distribution of earthquake coincide with the distribution of volcanoes. Those part you have to keep in mind. Now, depending upon word limits, if it is asking 250 words or 150 words, in which word it is being asked. If it is asking 150 words, you directly go with the distribution of volcanoes part. If it is not, if it is asking 250 words, you can also define what is volcanoes. You can also define what is volcanoes in the introduction. Fine. So either you can start with that volcanoes are the eruption of molten magmas from the narrow vent in the from the interior of Earth. From the interior of Earth. So you can define volcanoes are the eruption of molten magmas from the narrow vent from the interior of Earth. So this is the definition you can mention. If it is asking 250 words, or if it is not asking 250 words, you can directly write with the distribution part. Clear? Then you can mention that volcanoes are unevenly distributed. Volcanoes are unevenly distributed around the earth, around the earth, generally lying around the plate margin or interior of plates in case of hotspot volcanism. Clear? So this is how you can write regarding distribution part, that volcanoes are not uniformly distributed. Sometimes volcanic eruption will happen, sometimes it will not happen. So volcanoes are unevenly distributed around the earth, generally lying around what? Plate margins. So we discussed either they are occurring at the plate margin or in the interior of plate. When it is occurring in the interior of plate, it is called as which type of volcanism? Hotspot volcanism. So either you can find it on plate margin or you can find it on hotspot volcanism. This introduction you can write. If word limit are less, you can directly start with this part also. Volcanoes are unevenly distributed because question is more focusing on distribution of volcanic eruption. But 250 words are there, you can also define volcanoes in the introduction. So that depends upon the limit, you can change your answers. Fine?
So instead, can we write like how the volcanoes are leading to earthquakes?
No, that is the second part of question. No? How first you have to explain distribution of volcanoes, then you have to write how distribution of volcanoes coincide with how distribution of earthquake coincide with the distribution of volcanoes. Wherever volcanoes are happening, their earthquake is also occurring. How they are coinciding with each other. That you have to explain in the second part. First you have to explain the distribution of volcanoes part. Fine? So after introduction, then you can write the main answer. The main part you can write. The volcanoes are occurring at convergent plate boundary or divergent plate boundary. Convergent plate boundary or divergent plate boundary. Fine. The volcanoes are occurring at which type of boundary? Either we discuss convergent plate boundaries or divergent plate boundaries. At the convergent plate boundary, you write here which type of convergence? Oceanic or oceanic continent. Subduction happens, which causes the melting of plates, leading to eruption of volcano. Fine. So this you can describe regarding what? Regarding nothing but convergent plate boundaries. So example you can mention about what? Example you can mention about Pacific Ring of Fire. Pacific Ring of Fire. So oceanic, where it is happening? Like we discussed, near Japan, near Indonesia. Oceanic collision are happening, and oceanic continent where it is happening? Where it is happening? Between North American plate and Pacific plate, or between South American plate and Pacific plate. So this is okay examples of what? This is an examples of okay the convergent plate boundary where how volcanic eruptions are happening. Clear? Then at divergent plate boundaries, pressure is released due to divergence, which causes magma to erupt onto surface. Leading to formation of ridges. Example you can mention about what? Example you can mention about mid-Atlantic ridges. Mid-Atlantic ridges. Yeah. That's why you can mention about. That's why most of the volcanic eruptions occurs along Pacific Ring of Fire, comma, mid-Atlantic oceans, also, comma, Mediterranean region. That's why most eruption occurs along Pacific Ring of Fire because of convergence, mid-Atlantic because of divergence. Mediterranean region is another region where we discuss Mount Vesuvius, Stromboli, Etna, all those in Italy. They are erupting. Why they are erupting? Because they are again on convergent boundary. So convergence is something that is okay happening. So this why most of eruption is something that is okay happening over here. Fine. You can also mention some of the eruption are also occurring due to hotspot volcanism as seen in Hawaiian Island, Reunion Island. Fine. So those you can mention with regard to distribution of hotspot volcanism. Fine. So this is how your main answers will be there. How volcanic eruptions are being distributed. So they are distributed along plate boundary, mostly around plate boundary, either convergent boundary or divergent boundary. But some hotspot volcanism can also occur. So that's why leading to formation of which type of island, Hawaiian Island, as well as the Reunion Island. Fine. Any doubt regarding this one? Now you can make a map. You can make a map like this, world map, just to explain your wherever the eruption is something that is happening. So you can talk about what? So you can talk about this zone, that is Pacific Ring of Fire zone. You can talk about here Reunion Island zone. You can make about here's a bit of Hawaiian Island in the Pacific Ocean. This entire region, Pacific Ring of Fire zone. So you can mention about these areas as the major area where volcanic eruptions are happening. Clear? Now the second part says that how earthquake coincides with what? Volcanic eruption. So you have to write that since convergent plate boundaries lead to sudden release of energy sudden release of energy. Hence, the earthquake also occurs at all type of convergent boundaries. At all type of convergent boundary, whether it is what? Whether it is oceanic continent or continent. So since convergent plate boundary lead to sudden release of energy, hence earthquake can also occur at all type of convergent boundary. There is opinion. Clear? Volcanic eruption can also cause earthquake. That's why it can also occur at divergent boundary or in hotspot volcanism region. So we discussed volcanic eruption is also causing what? Earthquake. Remember various causes we have discussed with regard to earthquake. So what are the causes we have discussed with regard to earthquake? That natural causes and man-made causes. Natural causes were what? Tectonic movement. We discussed volcanic eruption. We discussed also what? Fault. If fault occurs, that is okay there. That all were the natural causes. And we discussed okay there can be also what? There can be also human causes. Human causes can also be there. Like we discussed mining, underground blast. That can cause also earthquake. So that's why you have to write since convergent plate boundary lead to sudden release of energy. Hence, earthquake can also occur at all type of convergent boundary. Volcanic eruption also cause earthquake. So that's why earthquake can also be seen at a divergent boundary and hotspot volcanism. Clear? So this indicate why earthquake and volcanic eruption always coincides with each other. But one more part that you have to add over here. What you have to add over here is earthquake can also occur. At conservative boundary or fault zone, comma, continent convergent boundary, where no volcanic eruption occur. So this line you also need to mention that earthquake can also occur at the places where no volcanic eruptions are there. They are also occurring at the places where volcanic eruptions are there, but they can also occur at the places where no volcanic eruptions are something that are there. Clear? So that line you also have to mention, because you know that Himalaya collision, Himalaya does not have no volcanic eruption. We discussed Himalaya do not have any volcanic eruption. Why? Because of continent collision. We also discussed that it can occur at a conservative boundary. Remember, conservative boundaries where plates are sliding past each other. When plate will slide past each other, then also earthquake can be generated. Like we discussed San Andreas fault in California, where plates are passing each other. There also earthquake can be generated. So that's why you have to mention this line to differentiate that earthquake can also occur at a boundary where no volcanic eruptions are occurring. Fine? Any doubt regarding this particular part? So these points you have to add in case of nothing but okay your answers. Fine? Clear? So lastly you can conclude with what? Conclusion, what you can write? Conclusion. Hence tectonic activity determines the spatial distribution of earthquake and volcanoes. So this how you need to nothing but okay finish your answer. Tectonic activity determines the spatial distribution. Spatial distribution is where okay they are occurring, in which spaces they are occurring. So both earthquake and volcanic eruption are generated due to tectonic movement. So tectonic activity determines the spatial distribution of earthquake and volcanoes. This is how you can finish with your answers. Fine. Fine. So clear now? Any doubt regarding what you have to write in answer and how you have to concise your answer? So the question was what? The question was explain the distribution of volcanoes around the world and distribution of earthquake, how it is coincide with the distribution of volcanoes. This is what the question were there. So as we discussed, you can directly start with what? You can directly start from here that volcanoes are unevenly distributed, not uniformly distributed. Some places it is occurring, some places it is not occurring. So unevenly distributed, and why it is unevenly distributed? Because it can occur due to hotspot volcanism, or it can occur due to nothing but plate marching. So that you have to write in case of introduction. Then you have to talk about how the plate marching, how you see nothing but how you see nothing but volcanic eruption are happening. If you have time, you can also make a subduction diagram, melting of plates over here, and how volcanic eruptions are something that are occurring. You can mention about that over here. And in this case, divergent boundary, you just mention about plates are diverging, leading to what? Leading to eruption of volcanic eruption. So here ridges are being formed. Here what is happening? Pacific ring of fire. So you have written, that's why most of the volcanic eruption occurs along, which are the reason? Pacific ring of fire, mid-Atlantic Ocean and Mediterranean region. These are the reasons where most of volcanic eruptions occur. Some eruption are also occurring in a hotspot volcanism as seen in Hawaiian Island, Reunion Island. So those are examples of what? Those are examples of hotspot volcanism distribution. Fine. Make a rough diagram of map and etc. You can show the regions where it is being distributed. Finally, you can write why earthquake and volcanic eruptions are coinciding, because wherever the convergent plate boundaries are there, collision will happen, energy will be released. When energy will be released, what will happen? Earthquake will occur. Wherever energy is not, collision is not happening, like in case of what? In case of hotspot volcanism or in case of the divergent boundary, volcanic eruption can trigger the earthquake. So that is the reason why earthquake coincides with what? Coincides with a volcanic eruption. But earthquake can also occur at a places where no volcanic eruption is occurring because of conservative boundary or because of continent convergence. Fine. So these are the points you can mention, and finally you can conclude with what? You can conclude with tectonic, how the tectonic activity determines the spatial distribution of earthquake as well as volcanic eruption. Fine? Anyone having any doubt? Clear? So how to concise your answers? Any doubt regarding this part? So now we were discussing about latitude and longitude in the last class, and also atmosphere and troposphere we have covered in the last class. So what is in which layer you see the jet movement or aeroplane movement? In the stratosphere. Which layer is making it possible the radio communication? Which layer is making it possible? Ionosphere, yes. What is the extension of mesosphere? Extension of mesosphere?
50 kilometers.
Yeah, 50 to 80 kilometers. And what is the properties of thermosphere? What is the properties of thermosphere? What is the properties of charged particles are going to be there? Also, as you go up, what will happen? Temperature will increase. So as you go up, temperature will increase. That part you have to keep in mind in ionosphere. Like we discussed, why troposphere is referred as a zone of turbulence. Yeah, all weather related phenomena occurs in troposphere. That's why it is referred as what? It is referred as a zone of turbulence. Fine. So those things we have discussed with regard to atmospheric composition and structure part. Fine. We started with latitude and longitude. What is latitude? Yeah, angular distance of a place on a Earth's surface from the center of the Earth, that is called as latitude. And what is longitude?
series of semicircle.
Yeah, series of semicircle that is connecting the North Pole to South Pole. Fine. Why prime meridian has been chosen?
Because it passes through
Why prime meridian has been chosen?
Greenwich.
Yes, because of we discussed in 1884 conference was done, and meridian that is passing through what Greenwich is being chosen as what? Chosen as the prime meridian. Fine. So we discussed the latitude is referred as what? Parallel, while longitude is referred as a meridian. Fine. Now, as we discussed, longitude not only helps in determining the position, that whether you are lying east or west of prime meridian, it also helps you determine what? It also helps you determine the time. It also helps you determine the time. Time of a place is determined through longitude. Time of a place is determined through longitude. So, as we discussed, both latitude and longitude are imaginary line we have drawn. Why we have drawn this imaginary line? To find the location of a place. What is okay? Location of place, whether it is north and south or whether it is east and west. We are trying to find the location of place, but longitude also helps in determining what? Determining the time. Clear? How it helps in determining the time? You know that Earth rotates on what? Earth rotates on its axis. So when Earth rotates on its axis, what will happen? What will happen? You see, in 24 hours, Earth is covering how many degree? 360 degree. Rotations means what? How many? Okay, one complete rotation means what? How much degree you are covering? 360 degree you are covering. So in 24 hours, Earth is covering how many degree? 360 degree. Clear? So in 1 hour, Earth will cover. In 1 hour, Earth will cover how many degree? In 1 hour, Earth will cover how many degree? That is 360 divided by 24. Clear? So in 24 hour, Earth is covering 360 degrees. So in 1 hour, Earth will cover how many degree? 360 divided by 24. So which is 12 to the 24, 12 to the 36. So you will have 15 degrees. So in 1 hour, Earth is covering how many degree? 15 degree. Fine. So 1 hour means how many minutes? 60 minutes. 15 degree you are covering in 60 minutes. So in 1 minute, how many degree you are going to cover? 60 divided by 15, that is 4 degree. Sorry. So in 60 minutes you are covering how many degree? 15 degree. So 1 degree you are going to cover in how many minutes? 60 by 15, that is okay, 4 minutes. So 1 degree is covered in how many minutes? 4 minutes. So Earth is rotating 1 degree in how many minutes? 4 minutes. That you have to keep in mind. Clear? So in 1 hour Earth is rotating how many degree? 15 degree. In 1 degree is being rotated in how many minutes? 4 minutes. So 15 degree in how many minutes? 60 minutes. So that is okay, what? Equals to 1 hour. Fine. Any doubt regarding this particular thing? So what we are saying is Earth is rotating on its axis. When Earth is rotating on its axis, in 24 hours, Earth is covering 360 degree. In 1 hour, Earth will cover 15 degree. And in 1 degree, Earth will cover in how many minutes? In 4 minutes. Fine. Now, let's say this is okay, what? This is Earth. This is Earth. This is Earth that you are finding. This is North Pole and this is South Pole. So this is North Pole and this is South Pole. As we discussed, Earth is rotating from which to which? Earth is rotating from west towards nothing but okay, east. So Earth is rotating from west to east. You know that sun position, sun is rising where? In the east. So as you are seeing, the first what will happen? First you will see eastern region, eastern part will see the sunrise. then what will happen? As the earth will rotate, we'll see western part is coming towards nothing but okay sun, so western part will nothing but okay see the sunrise. Fine. So first eastern part will see the sunrise, and then as the earth will rotate, we'll see western part is coming towards the sun, so western part is going to see the sunrise. Clear? So this is what happens in case of nothing but okay what? This is what happens in case of rotation of earth. That's why different regions have a different time when you see the sunrise and sunset, because earth is continuously rotating on its axis. Fine. Now suppose, so we are seeing prime meridian is how much? Prime meridian is how much? We are saying it is 0 degree. It is called as a 0 degree longitude. Prime meridian is called as which longitude? 0 degree longitude, that is okay there. Yeah. And India lies, prime meridian means it is passing through which? It is passing through London, that is Greenwich region, that is okay there. So whether India lies on the eastern side or India lies on the western side?
Eastern side.
India lies somewhere around this side. Clear? So India lies, this is UK, India lies on the east of nothing but okay what? On the east of UK. So which is the line that we have chosen as a standard meridian? We have chosen 18.2.5 degree longitude. We have chosen this longitude as what? We have chosen this longitude as India's standard meridian. Clear? Why we have chosen this longitude as India's standard meridian, or Indian standard time is determined through this longitude? Why we have chosen this one? Because if you see the extension of India, this is around 68 degree longitude, and this is roughly, Arunachal is around roughly 97 degree longitude. Clear? So 68 degree longitude to 97 degree longitude is India's extension. From here 68 degrees to here what is 97 degree. So 82.5 is what? Roughly in between of what? Roughly in between of these longitudes. So that's why India has chosen which longitude as its time zone. We have taken 82.5 degree as a time zone because it is roughly in the middle of what? In the middle of nothing but okay, both the longitude. That is extension of India. Fine. Any doubt regarding this one? So and you have to find out how much is the difference lies between the Greenwich Mean Time (GMT) and Indian Standard Time, that is okay there. How much is the time difference that lies between Greenwich Mean Time and Indian Standard Time? Clear? So as we discussed, how much is the difference in the longitude? 82.5 degree, because prime meridian is 0 degree, and here Indian meridian, as we discussed, Indian Standard Meridian is what? 82.5 degree. Clear? 82.5 degree. 82.5 degree, can you write it as what? Can you write this as 75 degree plus 7.5 degree? 82.5 can be written as this. 75 degree plus 7.5 degree. If you make it total, how much it will happen? 82.5 degree, that is okay there. So you can write 82.5 degree as 75 degree and 7.5 degree. Clear? Now we discuss in 1 hour, Earth is covering how many degree? In 1 hour, Earth is covering how many degree? 15 degree. Clear? So Earth will cover 75 degree in how many hours? 5 hours, because 15 5s are 75. So Earth will cover how many degree? Okay, 75 degree in how many hours? 5 hours. Clear? Earth is covering how much? Earth is covering 15 degree in how many hours? 1 hour. So Earth will cover 75 degree in how many hours? 5 hours. In 1 hour, if you are covering 15, in 5 hours what will happen? You cover 75 degree, that is okay there. Clear? So this is okay, 5 hours difference. And 7.5 is what? 7.5 is half of what? Half of 15. If you half of 15 you do, what is going to come? 7.5 is going to come. So 15 degree we are okay doing in 1 hour. So 7.5 degree in how many minutes we are going to do? 30 minutes, because half time we have to take. So 5 hours and 30 minutes. So this is the difference between Greenwich Mean Time and Indian Standard Time. How much difference is lying between Greenwich Mean Time and Indian Standard Time? 5 hours and 30 minutes, that is okay there. Now this 5 hour 30 minutes will be ahead time or behind time? It will be ahead time. Why it will be ahead time? Because as we discussed, India lies on the east. So sun rises where? In the east. So that's why first we are ahead. Then what will happen? You will see nothing but okay, this particular region. So that's why if it is 12 o'clock where? If it is 12 o'clock in London, it will be how much in India? 5:30 p.m. in India, because we are 5 hours 30 minutes ahead of nothing but okay, Greenwich Mean Time. Clear? So this is how we determine the time based on what? Based on nothing but okay, longitude. Clear? Any doubt regarding this particular thing?
Because of the meeting held in the Greenwich Mean Time, they have decided.
Yeah, because of the meeting that was called in 1884, the line that is passing through Greenwich is chosen as what? Prime meridian, reference line. Clear? Because as we discussed, any line you can choose. Because if you choose any line, what will happen? 360 degrees is going to come. But reference line has to be taken. That's why that is there. In 1884, who was the powerful country? British were, okay, they were colonizing. So British, Germany, France, okay, they were the colonizing power. So 2-3 countries decided that okay, what? That we are going to choose this as a line. But okay, now that has now become what? Prime meridian now. So we are taking that as a reference line. Fine. Any doubt regarding this particular thing? So that's why you can get a question in the prelims like this. Let's say you can get a question if there is 5 p.m. of 5 p.m. at 150 degree west meridian, 5 p.m. of Thursday at 115 degree meridian, what will be the time? What will be the time? What will be the time at 87 degree east meridian? Like this you can get a question. Clear? If there is a 5 p.m. of Thursday at 150 degree west meridian, what will be the time at 87 degree east meridian? Calculate and tell me. Calculate and tell what is the time you are going to get.
It
12 p.m. of same day or different day? Of next day. 12 p.m. of 12 a.m. of Friday. Anyone else? Okay. So when we are talking about 87 degree, prime meridian, it is 87 degree east. When we are talking about 150 degree west, it is from where? It is from nothing but okay, prime meridian. Clear? So this lies on the western side and this lies on the eastern side of the prime meridian. Because west and east, how we determine? From the prime meridian we determine the west and east. So what is the time over here? Time over here is 5 p.m. of Thursday. Now what time you calculate? What is time over here? So first of all, how we calculate the time? We have to find out the differences between whom? Differences between the longitude or meridian. How much is the difference? So here what? Well, how much this distance is there? 115 degree. How much this distance is there? 87 degree. So total difference is how much? Total difference is 7, 5, 12, 8, 1, 9, 1, 10. So total difference is how much? 202 degree. 202 degrees are difference. Clear? Any doubt regarding this particular thing? Now, we have to now see how much is the time difference. You know that Earth covers how many degree?
5 a.m.
Earth cover how many degree? 15 degree in what? 1 hour. So let's say 15 ones are 15. So you will get 5, 52, 15 threes are 45. So how much is there? So you will see how much difference is coming. 13 hours and what remainder is coming? 7 degree. Okay, what remainder is coming is 7 degree. Fine. So if you multiply 15 into 13, how much you are getting? If you multiply 15 into 13, how much you are getting? 3 5s are 15 and 13 ones are 13, 1. 3 5s are 15, 13 ones are 31, 195. Okay, so you are getting nothing but okay what? You are getting nothing but okay 195 degree. Clear? So how much is left? 27 degrees left, no? 195 is covered. Okay, how much is left? 7 degree. You know that 1 degree how many minutes?
4 minutes.
7 degree how much? 7 into 4, that is 28 minutes. 7 degree how many minutes? 28 minutes. So what will be the difference in time? 13 hours and 28 minutes. Will it be ahead or will it be behind? Ahead, because this is a west meridian and this is nothing but okay, east meridian. So now I have to add 13 hours. So if I add 13 hours, what will happen? From 5 p.m. to 5 a.m. 12 hours, then 6 a.m. 13 hours and 6 and 28 minutes. So this is going to be what? This 6:28 a.m. This is going to be time at this of which day? Of next day. Thursday means Friday will be there. So if there is a 5 p.m. of Thursday that you are finding at 115 degree west, you will have what? You will have 6:28 a.m. of Friday on which meridian? On 87 degree east meridian. Fine. So this is how we calculate nothing but okay time. This is how we calculate the time. So whenever question is being asked to calculate the time, how you are going to calculate? First off, find out the differences between meridian and then try to okay what? Try to nothing but okay see how much degree is being covered in how many okay hours and minutes that you see it, and then find out whether it is ahead or behind. Fine. So this is how you're going to calculate. I'll give one more. Just try to calculate it. Try to find out.
So can you go to the previous slide once? So after having 7 degree, the third step is like 15 into 13.
No, I'm just saying that if you divide 202 degrees the difference. Now we have to divide this 202 degree with 15 degree because we know that 15 degree earth covers in how many hours? 1 hour. So to cover 202 degree, how much time it will take? First is 13 hours. Okay. So if you are covering 15 into 13, if you are doing, how much is coming? 195. What is the remainder that is coming? 7 degree. So this 7 will not be cancelled, no. So 7 degree in, we discussed earth is covering how many degree in 4 minutes? 1 degree. So in 7 degree they will cover in how many minutes? 28 minutes. So total will be 13 hours and 28 minutes of difference that is going to be there. Fine. 13 hours and 28 minute difference. Okay. So 13 hours till 195 and rest, okay, 7 degrees, okay, what, 28 minutes. So that difference is going to be there, 13 hours, 28 minute difference. Fine. Now you calculate this one.
So previous day 1 o'clock 40 minutes.
Saturday,
Saturday
40
p.m.
1:40 p.m.
PM.
This is AM. This is AM.
1:40 a.m.
1:40 AM. Fine. Anyone else? Still not getting. Look, what is there is make, whenever question is given, make prime meridian 0 degree. Then what meridian is given? 171 degrees. So 171 will lie somewhere here, east of nothing but okay, east of nothing but okay, prime meridian. What is the time given over here? 3 AM Sunday. That is the time given over here. Now you have to find prime, which distance you have to find at 16 degree east. So 16 degree east means it will also be on this side, not on the other side of the prime meridian. So you have to find time at this point. So first of all, what is the difference between these two meridian? How much is the difference? So 171 minus 16, because both are on the same side. Earlier we discussed one was here and one was here. So we were adding the time, but here what is happening? Total difference of degree will be how much? 155 degree. Clear? So you know that in 155 means what? If you divide it by 15, 15 ones are 15, this will get cancelled, 5, 10. So you know that what will happen? 10 hours is going to be there and 5 degree which is left. 5 degree will be covered in how many minutes? 5 degree will be covered in how many minutes? 20 minutes. 1 degree in 4 minutes. So 5 degree will be covered in how many minutes? 20 minutes. So difference of how much will be there? Difference of 10 hours and 20 minutes are going to be there. Difference of how many is going to be there? 10 hours and 20 minutes is going to be there. Okay? 10 hours and 20 minutes. Now, this will be what? This will be ahead or behind? 10 hours and 20 minutes will be ahead or behind? Behind. Okay, because this sun will be first seeing this one and then coming to nothing but okay, this one. Eastern side will have more. So this is behind. 10 hours 20 minutes behind. So we have to subtract 10 hours 20 minutes from 3 am. Clear? We have to subtract it from 3 am. So it will become what? It will become 5 pm if we are taking up 10 hours. And you will also see 20 minutes further we have to subtract. So it will become 4:40. It becomes 4:40 pm of what? Saturday. So this is going to be time. 4:40 pm of Saturday. This is going to be time. Fine. Any doubt regarding this one? So if you subtract 10 hours and 20 minutes from 3 am, what will happen? You are going to get 4:40 pm of what? 4:40 pm of Saturday. Fine. Any doubt regarding this particular thing? So remember, whenever any distance is given, it is given with reference to prime meridian. So if it is okay talking about two sides of prime meridian, you just have to add meridian. If it is talking about same side of prime meridian, you have to go for subtracting the meridian. Fine. Let's say one more you solve it. Anyone?
Around 4,
Around
4 a.m. it will be.
4 a.m. of same day or different day?
Same day, sir.
4 a.m. Sunday. Fine. So as we discussed, what is given? This is given as a 10 degree west, and what is being determined? 149 degree west. So it will come over here. And the time is given as what? Time is given over here as 7 p.m. Sunday. So time is given over here to find over here. So first of all, what is the difference between these two? How much is difference? Both lies on the same side. So what you have to do? You have to do the subtraction. 149 minus 10 degrees. So how much is the difference? 139 degrees. So difference of how many difference is there? 139 degrees there. Now, how much? The time difference. So 15 nines are 135. So you see 4. So 9 hours and 4 degree will be covered in how many minutes? 16 minutes. So 9 hours 16 minutes of difference is there. 9 hours 16 minutes of difference is there. Will it be ahead or behind? Will it be ahead or behind? It will be behind, because okay, first this side of west will face, then what will happen? This side of west sun will come. Clear? So behind it is going to be there. Clear? So when behind, so we have to subtract 9 hours, okay, and 16 minutes from 7 p.m. We have to subtract 9 hours 16 minutes from 7 p.m. Fine. So what will happen is, okay, what if you subtract 7, 12, and then it will come as 10 and 9, so we get 9:44. 9:44 a.m. of Sunday. So if you subtract 9 hours and 16 minutes from 7 p.m., what you are going to get is 9:44 a.m. of fine, same day you are going to get. Clear? So this is how the things are being calculated. Clear? Any doubt regarding this one? So simple thing, simple rule, what you have to keep in mind is what? If, okay, what? If the distance meridian are being given, first you have to draw a reference line, prime meridian, and see whether they are lying on the opposite side of prime meridian. If they are lying on the opposite side of prime meridian, what will happen? Then meridian will be added up. Difference between meridian will be added up. Clear? Like in this question, what had happened? In this question, what had happened? One is lying on one side, another is lying on the other side. So what we have done is what? We have added up the meridian, that is okay there. But if they are lying on the same side, if they are lying on the same side of prime meridian, then what will happen? You have to nothing but okay subtract it. For example, here 16 degree and the 171 degree both lies on the same side. So you have to what? You have to subtract the meridian, that is okay there. So first you have to find out which side of prime meridian they are lying, then add it or subtract it, that is okay there. Then find out okay the differences, that is okay there. And lastly what will happen? See whether it is ahead or behind. So based on ahead or behind, you can nothing but okay what? You can add it up or subtract it up. Fine. So that's why if you see India, we discuss India is extending from where to where? India is extending from 68 degree over here to what is happening? 97 degree where? In the Arunachal. So here you will find okay how much is the difference? 97 degree east. So how much of the difference you are having? As we discussed, around 29 degree difference. From here to here, how much is the difference? 29 degree difference is something that is okay there. Clear? So that 29 degree means how many hours? 29 degree difference means how many hours? 15 degree, 1 hour. So 29 degree means okay, almost how many hours? 2 hours. 30 degree means 2 hours. So 29 degree means almost 2 hours. Okay, so that's why you will see our northeastern region, that is Arunachal, is going to see sunrise 2 hours before than what? 2 hours before than the Gujarat part, which is the west part. Clear? Why? Because it is 2 hours ahead. Okay, what? It is 2 hours ahead of nothing but okay this longitude. Clear? So you see time changes at every meridian. Clear? So if you are traveling from here to here, then what will happen? You have to keep on adjusting your clock, okay? Because time changes with every meridian. What will happen? Time changes, so you have to keep on adjusting your clock. Okay, that is okay there. That's why to avoid this problem, only we have chosen what? We have chosen a standard meridian, that we are going to allocate time based on this meridian, that is okay there. And why the IST has been chosen? Because it lies in the middle of nothing but okay both meridian, that is okay there. Clear? So that's why 82.5 degree meridian has been chosen this as a Indian standard time, so that whenever you are moving from one location to another location, what will happen? One location to another location, what will happen? You don't have to change continuously the time, one time across India, and that is why this meridian has been taken. Fine. Any doubt regarding this particular part? But there is a problem. If the stretch of the country is much bigger, then what will happen? Like in Russia, you see Russia is extending from where to where? From this part to nothing but okay Europe part. If Russia is extending like this, what will happen? If let's say you are taking one time June, one standard meridian, then what will happen? If Russia chooses one standard meridian, then what will happen? Let's say if this this region, there may be difference of how much? There may be a difference of around 15 hours. There may be difference of around 15 to 16 hours. Okay, in what? In this side to this side. Clear? So this side may see sunrise 15 hours before than what? The other side, that is okay there. There may be difference of 15 to 16 hours. Clear? So that's why you can't choose one standard meridian over there, because if you are choosing one standard meridian, then there will be difference of 15 to 16 hours. So here day is happening, there night will be happening. So that's why Russia has a different time zones. They do not have one time zone, they have a different time zones. Okay, that is okay there, because stretch of the country is much bigger. Clear? Even demand in India is also there for 2 time zones. Why there is a 2 time zone? Because we discussed northeastern region, see what? The sunlight 2 hours earlier than what? 2 hours earlier than this one. Let's say your office timing is what? Office timing is 10 to 6 in India. Let's say this is the timing, office timing. Then what will happen? If sunrise is happening at around 6 a.m. or 5 a.m. in case of northeastern region, let's say 5 a.m. sunrise is happening. So here at which time sunrise will happen? Around 7 a.m. Okay, because difference of how much hours is there? 2 hours of difference. So here if sunrise is happening at 5 am, here sunrise will happen at which am? Sunrise will happen at a 7 am. Here if sunset is happening let's say around 5 pm. So here sunset will happen at which pm? Sunset will happen at nothing but 7 pm. So here sunset is happening at which pm? 5 pm. So here sunset will happen at 7 pm. Difference of 2 hours is going to be there. Clear? Now if you keep office timing from 10 to 7, what will happen across India? Then what will happen? After 5 pm, what will happen? Sunset is there. When after 5 pm sunset is going to be there, what will happen? You have to use more of artificial lights. You have to use more of which type of light? Artificial light, because sunset is there and now you have to switch on your own artificial lights to power things. That is clear? Children will not have time to play and etc. That is there, because already sunset is there. Other things are there, so sports activities and other activities will not be taken up. Clear? But that can be possible over here, because here daylight time is there till when? Till 7 pm it is there. So here after 6 you can dedicate things for there. Clear? So that's why having 2 time zones will solve these problems. Having 2 time zones will solve this problem. Let's say here we have 10 to 6 as a timing. Here we can keep 8 to 4 as a timing, so that they can also have nothing but sufficient time. So having 2 time zones will be beneficial. That's why the northeastern demands the 2 time zone, that India should also have 2 time zone instead of nothing but 1 time zone. But government is still not Government has still not decided on 2 time zone, because as we discussed, problem will happen when you move from one areas to another areas, and there will be also coordination issues. Why coordination issues? Let's say at 5 pm from Gujarat, if you have to send some official thing to the northeastern, what will happen? You can't send, because their office timing is only till 4 pm. That is there. Clear? So that's why you can't have a coordination throughout the countries. That is going to be problematic. So that's why having 2 time zones is a bit problematic, and that's why government is not agreeing on that. Clear? So this is what we call as a DST. This is what we call as a DST, called as a daylight saving time. Called as a daylight saving time. Daylight saving time. Daylight saving time is utilizing more of what? More of nothing but sun instead of switching to artificial light, utilizing more of nothing but sunlight. That is called as what? That is called as a daylight saving time. Fine. Any doubt regarding this particular aspect? So this is how we determine the time. Longitude helps us to determine what? Time also. Longitude also helps us to determine places, whether it is east or west of nothing but what? West of meridian. Fine. Any doubt regarding this one? Now there's one more thing that you have to keep in mind. Fine. So this is what you are finding. Here, this line is what? This line is called as a which meridian? Prime meridian. So we have discussed this line is called as a prime meridian. It is a 0 degree. Clear? Now, when we are moving from 0 to here, that is 180 degree, I can move from 0 to 180 degree this side. I can move from 0 to 180 degree towards something but what? 180 degree towards something but this particular side. Clear? So 1 degree, how much difference will come? 1 degree, 4 minutes, and 15 degree, how many difference will come? 1 hour. Clear? So if I'm moving this will be what? This will be 1 hour, this will be 2 hour, this will be what? 3 hour, 4 hour, 5 hour, 6 hour, 7 hour, 8 hour, 9 hour, 10 hour, 11 and 12. So at 180 degree, how much is the difference you are finding? At 180 degree, what will be the difference between prime meridian and this? 12 hours difference is going to be there. Clear? Now if I go back similarly, what will happen? This part will be 1 hour behind what? 1 hour behind prime meridian, 2 hour behind prime meridian, 3 hour, 4 hour, 5 hour, 6 hour behind prime meridian, 7 hours, 8 hours, 9 hours, 10 hours, 11 hours and 12 hours. Okay, so this also will be nothing but okay 12 hours behind prime meridian. So 180 degree you are covering over here and 180 degree you are covering over here. Clear? So if you see, if you take this point as 180 degree prime meridian, if I take this point as a prime meridian, I can move 180 degree this side, I can move 180 degree this side. If I am moving 180 degree this side, I am going to come at this point, and if I am moving 180 degree this side, I am going to come at what? A single point only, you know. Because Earth is globe in nature. When it is globe in nature, what will happen? Whether I am moving 180 degree this side or whether I am moving 180 degree this side, ultimately I am going to come at what? The same meridian only, 360 meridian. 180 means this side and 180 this side means what? 360 meridian, that is okay there. So this is prime meridian, 0 degree is prime meridian and 360 is what? 360 is another meridian, that is okay there. Clear? Any doubt regarding this one? So assume this side, this line. So this line as we are moving up, we discuss it is 12 hours ahead of what? It is 12 hours ahead of the what we call as a prime meridian. If I am going back towards this side, this part will be 12 hours behind what? This will be 12 hours behind the prime meridian. Okay, this will be 12 hours behind the prime meridian. Why? Because this lies on the western side of the prime meridian. Earth is globe in nature. Clear? So this is 12 hours ahead and this is going to be what? 12 hours behind prime meridian. Clear? India. So what will be the difference of time? What will be difference of time in these two places? 1 day, 24 hours difference will be there because this is 12 hours ahead of prime meridian. This is 12 hours behind the prime meridian. So difference will be how much? 24 hours. So if you are moving from, let's say, this part of Russia to this part of USA, that is Alaska, then date is going to change because difference is how much there? 24 hours difference is there. 24 hour difference means what? Date is going to change. So let's say here if it is 5 p.m. of Sunday is there, here if it is 5 p.m. of Sunday is there, this side what will be the time? 5 p.m. of Saturday. How much is the difference is going to be there? 1 day difference will be there. So here if it is 5 p.m. of Sunday is there, here what will be the timing? 5 p.m. of Saturday will be there. 1 day difference will be there. Clear? Any doubt regarding this one? So let's say a person moves from here to here. This is okay, the line we are taking 180 degree line. This is the line. If person moves from here to here, that is let's say from Japan towards nothing but okay US, what will happen? So this is west of this line, this is nothing but okay east of this line. Okay, so we are saying that if you are moving from west towards the east across from Japan to Alaska, what will happen? What will happen? A person will lose a day or gain a day. What will happen? What will happen to the person if he is moving from west to east? Now assume what is the time over here at the Japan? Assume 5 p.m. of which day is there? Sunday is there. What will be the time in Alaska, this region? I'll clean everything. So this is okay what? This is 180 degree line we are seeing. As we discussed, difference between these 2 points is how much hour? 24 hours. Clear? So if I am taking this region, let's say here 5 p.m. of Sunday is there. What time here will be there? 5 p.m. of Saturday. Clear? So now when you are moving from here to here, that is west towards east, whether you are going to gain a day or whether you are going to lose a day? Gain a day. Why you are going to gain a day? Already you have okay spent what Saturday over here. Now you have come to what? Sunday. But here what is there? Saturday is there. Again you have to spend Sunday. Okay, over here. So you are going to what? You are going to gain a day. But if you are moving from here to here, east to west, then what will happen? You will lose a day because here you have to yet to spend Sunday, but here what is happening? Sunday is already gone. Okay, 5 p.m. is already there. So what will happen? You will lose a day. Clear? So that's why this line is referred as what? This line is referred as ideal, international date line. Clear? This line is referred as what? Ideal international date line. Clear? So when we are moving from here to here, prime meridian to 180 degree, 12 hours ahead. When we are moving here to here, what is happening? 12 hours behind. Difference is going to be there from what? Difference is going to be there for 24 hours. So that's why if a person moves from here to here, he'll lose a day, or here to here, he'll gain a day, depending upon nothing but okay scenario. Fine. Any doubt regarding this particular part? Any doubt?
Day and night will also change in the atmosphere also.
Day and night will also change it.
Atmosphere also it will change.
Yeah, atmosphere also it will change.
So that also it will change.
It will change because okay, Earth is rotating, no? So let's say this is 180 degree west part, this is 180 degree nothing but okay east part. Now this will go behind, this will come up. So this is sun. So it is coming. When it is seeing east, here what will happen? Here nothing but okay, the night will be there because this is okay sunlight, daytime over here. Here what will happen? Night time. Then okay, what will happen? Then further rotation will happen. Here daytime, here night time. So you'll see a change in what? Change in nothing but okay, date will occur, and this difference is called as what? This difference is called as an international date line. Clear? So what you have to keep in mind is moving from west to east across ideal international date line. Moving from which side to which side? West to east across ideal. A person will gain a day. A person will gain a day. And moving from east to west across ideal, a person will lose a day. Lose a day. This you keep in mind. When you are moving from west to east across which line? Across international date line, you are going to gain a day. When you are moving from east to west, you are going to what? You are going to lose a day. Clear? So if you are moving from here to here, already you have spent Saturday over here. Again you will spend what? Again you will spend Saturday over here. So what will happen? You will see what? You are gaining a day, but here to here, if you are moving, you are going to lose a day. Fine. But this international date line is not drawn in a straight manner. Like prime meridian, you can see it is okay, mostly in a straight line. International date line, when you look at okay, what? When you look at international date line, I'll just show in another map. So you can see this is how the international date line is being drawn. It is not drawn in a straight line, it is drawn in a zigzag line. Why it is drawn in a zigzag line? Why it is drawn in a zigzag line, not in a straight line? This is 180 degree only. But you see here, okay, it is being drawn like this. Okay, it is being drawn like this, not exactly like a straight line as you see in the prime meridian. Clear? Why this is not happening? Because to avoid a change of date between close location, if it passes through this only, then here you see 1 kilometer of difference may be there, and they'll have a different date. Okay, they'll have a different date, different times. Okay, that is okay there. So to avoid confusion in the people living nearby, we have drawn international date line in a what? Zigzag manner, not in a straight manner. Fine. Any doubt regarding this one? So this is important part you have to keep in mind with regard to international date line. Fine. So you may get a question like this. which is the correct statement? Both are correct. Anyone else? Anyone else? We discussed that this is okay what? This is a line, this side is what? Japan, this is nothing but okay what? This is Alaska. If you are moving from here to here, what will happen? Here it is 5 p.m. of Sunday, then here will be what? 5 p.m. of Saturday. So if you are moving from west to east, what is happening? Gaining a day. If you are moving from east to west, what will happen? You are losing a day. But this is happening across which line? International date line. It is not happening across what? Prime meridian. Prime meridian is what? 0 degree. If you are moving from here to here of prime meridian, what is happening? Difference of 1 hour or 2 hours is going to happen. Not date change will happen. Date change will happen when? When you are moving across international date line, that is okay there. Clear? So here what is okay written is prime meridian. So that is okay. Wrong statement. Both are something that are wrong statements. So read statement carefully what it is given. East to west of ideal it is given, or east to west of nothing but a prime meridian it is given. So that will determine whether okay you are going to gain a day or lose a day. Fine. Any doubt regarding this one? So remember, ideal is what? Ideal is not a straight line. 180-degree line is ideal, but it is not a straight line drawn in a which manner? Zigzag manner, so as to avoid date change within a within a closed locations. Fine. Any doubt regarding this particular part? So remember, longitude determines what? Time. With every with every degree rotation, with every degree Earth is covering in how many minutes? 4 minutes, and in 1 hour, they are covering how many? 15 degree. That's why time changes every meridian. Clear? And to avoid this confusion amongst people of time change, we choose a standard line or standard time. So what is India's standard meridian? India's standard meridian is 82.5 degree meridian, which is how much ahead of the Greenwich Mean Time? 5 hours and 30 minutes ahead of Greenwich Mean Time. Fine. Any doubt regarding this particular part?
Moving when example as Australia when they are according to India, Earth is also rotating also. So Australia is at 5 hours ahead. They will gain. They will leave at 5 o'clock in the evening. They will arrive here also at the 5 time, 5 p.m. Still moving that.
They, let's say okay what will happen is okay they are leaving Australia at some 5 p.m. and let's say the difference between timing is 3 hours. Clear? Difference in the timing of India and Australia is 3 hours. Fine. So what will happen is okay what will happen is when they come to India, they'll come to India at, let's say Indian standard time is okay at this time 5 p.m. Australian standard time is what? Australian standard time here is 8 p.m. So he is leaving at 8 p.m. and he is coming to India. So when he will reach India, India will have what? Let's say 3 hour journey is there. India will have 8 p.m. Australia will have how much p.m.? 11 p.m. Clear? So what will happen is okay what? He is okay leaving Australia at 8 p.m. 3 hours journey. So at Australian time 11 p.m. he will reach India, but Indian time at Indian time 8 p.m. he is going to nothing but okay reach India. So this is how we have a difference. So when you go to different country, you have to adjust time zone as per that country that is okay there. Fine. Any doubt regarding this one? So have a break and then we'll further continue.
Sir, ideal starts at 180 degrees.
Ideal Fine. So now we are going to take up some certain facts. So these are what? These are the countries that are touching the prime meridian. So in UPSC you may get this sort of question that which of the countries are located on prime meridian. So note down the name: United Kingdom, France, Spain, Algeria, Mali, Burkina Faso, Ghana and Togo. These are the countries that are lying on prime meridian. So first is UK. You can see this is a Greenwich. Then what is happening? France is there. Then what is happening? Spain is there. Then you see Algeria. This is Algeria. This is nothing but okay Mali. You can see Burkina Faso, Ghana and Togo. These are the countries that are lying on prime meridian. Fine. So quickly note down the name of these countries which are lying on prime meridian. So these are lying on prime meridian.
What is that eighth one, sir?
Togo, T-O-G-O, Togo. Okay. So three countries of Europe: UK, France, and Spain, and rest Algeria, Mali, Burkina Faso, Ghana, and Togo. These are of African countries. Fine. Now these you lie right. These are the state which are touching Indian Standard Time. So IST is passing through what? UP. IST is passing through Chhattisgarh. It is passing through Odisha. It is passing through Andhra Pradesh. Fine. So just write down through which state IST, Indian Standard Meridian, is passing. Write down. IST passing through how many states? It is passing through Uttar Pradesh, it is passing through Madhya Pradesh, it is passing through Chhattisgarh, it is also passing through Andhra Pradesh, you can write also. Fine. Then you can also write countries which are crossing the equator, which are touched by the equator, or equator is passing through how many countries? Just note down the name of Colombia. So three countries over here: Colombia, Ecuador and Brazil. These are the three countries in South America. Then you have Sao Tome, Gabon, Congo, Uganda and Somalia, Kenya. Clear? So these countries are African countries. So Colombia, Ecuador, Brazil. Fine. Then Sao Tome, Gabon, DRC, Uganda, Somalia, Kenya. So these are there. Then you can see Maldives and Indonesia. So Maldives and Indonesia along with Kiribati Island.
Should we write those two, sir? The Republic
all Africa. Congo is also there, Kenya is also there, Somalia is also there. It's passing through all these countries. Fine.
Sir, you mentioned of solar graph painting also.
Which is the
Solar graph painting. In the which is the solar? Put the continent is also.
South Africa is only this part. The bottom part is South Africa.
The next part is solar.
Yeah, the whole continent is African continent, only the bottom part is South Africa.
And which one is situated?
Huh?
West Indies.
West Indies is this Caribbean island. So we discussed Antilles now, Greater Antilles and Lesser Antilles. The Lesser Antilles, okay, combines the West Indies part. Right? The next you can mention is Tropic of Cancer. Which are the countries lying on Tropic of Cancer? So you can write Mexico, Bahamas, Western Sahara, Mauritania, Mali, Algeria, Niger, Libya, Egypt, Saudi Arabia, UAE, Oman, India, Bangladesh, China, Myanmar.
Should we read that also for questions?
Which one?
With that interlinked questions are
Yeah, Mexico, Bahamas, then Western Sahara, Mauritania, Mali, Algeria, Niger, Libya, Egypt, Saudi Arabia. They are all these countries through which Tropic of Cancer is passing. Then in Asia, you have Saudi Arabia, you have UAE, you have Oman, India, China, Bangladesh, Myanmar, all these they are finding. So prelims factual based questions are going to come from equator, countries passing, countries through which equator is passing, countries through which Tropic of Cancer or prime meridian. Clear? Then, so India, China, Bangladesh and Myanmar. You can add those. Now, for Tropic of Capricorn, mention the Chile. First is what? Chile. Chile, Chile, Argentina, Paraguay and Brazil. Chile, Argentina, Paraguay and Brazil. These are four lying on Tropic of Capricorn. Chile, Argentina, Paraguay and Brazil. Then here you have Namibia, Botswana, South Africa, Mozambique and Madagascar. Namibia, Botswana, South Africa, Mozambique and Madagascar. Mozambique and Madagascar. Botswana, Namibia, South Africa, Mozambique and Madagascar.
Tropic of Capricorn.
Then you write Australia. Right, Australia. Fine. Now you can write this, the state through which Tropic of Cancer is passing in India. State through which Tropic of Cancer is passing in India.
So Tripura is also like that.
Yeah. Tripura, Mizoram. So Gujarat, MP, Chhattisgarh, Jharkhand, Bengal, Tripura and Mizoram. Right. Add one line after writing this. Some cities which are closest to the Tropic of Cancer are Ujjain, U-J-J-A-I-N, Ujjain,
Can you spell it, sir?
U-J-J-A-I-N, Ujjain. Ujjain lies in Madhya Pradesh. Then Damoh, D-A-M-O-H, Damoh, comma Ambikapur, in bracket you write down Chhattisgarh. Ambikapur lies in Chhattisgarh, comma Ranchi, Jharkhand, comma Amarpur, A-M-A-R-P-U-R, Amarpur, Tripura. So these are the cities that are located closest to what? Closest to Tropic of Cancer. Fine. Now one more you added, the countries touched by Arctic Circle. Countries touched by Arctic Circle. Right on Canada. First is Canada. USA. Canada and USA. Then Norway, N-O-R-W-A-Y, Norway. Sweden, S-W-E-D-E-N, Sweden. Comma Finland, F-I-N-L-A-N-D, Finland. Comma Russia, comma Iceland. Finland, comma Russia, comma Iceland. Fine. And there is one more region which is called as a Greenland. So this line that you are seeing is what? This line that you see is Arctic Circle. So you can see this dotted line. This dotted line is which line? This dotted line is your Arctic Circle. So it is passing through Alaska, which is US part. It is passing through Canada. It is passing through what? this part, Greenland lies in Denmark. So it is currently controlled by Denmark. Though Denmark is a European country, but Greenland is okay there. So you can add Denmark also. You can add Denmark also as one of the country through which this is passing. Clear? So Denmark is not directly being touched by, as a country, Denmark is not directly being touched by, but Greenland is what? Greenland is being controlled by the Denmark currently. Fine. Then you will also see what? Then also see these part, which is Norway, Sweden and Finland. They are being cut, and you can see here is the Denmark. Clear? So Denmark is a European country, lies over here, much lower than Arctic Circle, but because Greenland is being controlled by Denmark, you just write Denmark also. So Norway, Sweden, Finland and Iceland, this is Iceland being touched, and finally you have what? Finally you have Russia, which are being touched by this circle, Arctic Circle. Clear?
So in example, they give like option Greenland should be marked as part, so
If Greenland is given as an option, just it is passing through. If Denmark is also given as an option, you have to make it correct, because Greenland is controlled by Denmark.
so Greenland or Denmark, whatever they do, we should mark.
Yeah, you have to mark it.
Both will come in Denmark. If both will come in.
Both will come. Both will not come. Both will not come. Let's say they will give either Tropic of Cancer passing through India or Tropic of Cancer passing through Madhya Pradesh. Yeah. So Madhya Pradesh is part of India. Clear? So what you see is okay. Both will not they will give. Either they will give name of the countries or individual island, like Greenland they can mention, Iceland they can mention, Hawaiian Island they can mention. Name of the island they can given and ask which is okay what, through which it is passing through. Fine. So these are okay what, these are important lines that you have to keep in mind, and these lines are passing through what, these lines are passing through which country you have to keep in mind. Fine. Which of the following country is cut by equator?
First things.
First three: Gabon, Congo, and Sao Tome. Anyone else? All.
Can you? Yes, sir. All five.
All are being cut by equator. So like this question can be coming in the examination. That which are the being cut? So Gabon is cut, Congo is cut, Sao Tome is cut, Kenya is cut, Somalia is cut. Fine. Now, you have to keep in mind. Now we are moving to concept of rotation and revolution. Rotation and revolution. So, as we discussed, Earth rotate on its axis from where to where? From west to east. So rotation on its axis. And revolution is what? The movement around sun. Movement around sun is called as revolution. And this revolution generally in which type of orbit? Elliptical orbit. So revolution happens in which type of orbit? Elliptical orbit. So rotation is Earth rotate west to east on its axis. Well, movement around sun in an elliptical orbit is referred as what? Is referred as revolution. So that difference you have to keep in mind. Clear? Now, Earth takes around 4 hours to rotate on its axis. Roughly, it is 23 hours 56 minutes. Roughly, it takes around 24 hours, and roughly around 365 days. So it is 365 days plus certain, okay, what certain extra, that's why we have a leap year. So 365 days roughly it will take to revolve. Okay. Now, the rotation causes change in day and night. Change in day and night. While revolution causes change in season. Change in season. So rotation causes day and night, while revolution causes what? Revolution causes change in season. Clear? Clear? Now, what you have to keep in mind, Earth is slightly tilted on its axis. So Earth is not like this. Earth is slightly tilted on its axis. It is like this. Yeah? So Earth is slightly tilted on its axis. It is not exactly horizontal. It is slightly tilted on its axis, which is making around 23.5 degree with the normal, and around 66.5 degree with the orbital plane. So Earth is tilted on its axis. Earth is making around 23.5 degree from the normal. This is normal. This is tilting of axis. So it is making around 23.5 degree from the normal and 66.5 from which plane? From the orbital plane. Orbital plane is a plane. Orbital plane is a plane around which Earth revolves around whom? Earth revolves around the Sun. Clear? Now this tilting of Earth causes what? This tilting of Earth causes the change in length of day and night. Change in length of day and night. So revolution as well as revolution as well as tilting of the Earth causes the change in length of day and night. Clear? Now this tilting is the reason so let's say this is the Sun, and this is an elliptical orbit around the Sun, and this is the Earth. This is nothing but the Earth. Now what you're finding is, as we discussed, Earth is what? Tilted on its axis. Now assume this part is what? This part is your Tropic of Cancer, Tropic of Capricorn, and what? Equator. Clear? So there are 3 lines we are talking about: Equator, Tropic of Cancer, and Tropic of Capricorn. And you also have 2 poles, one over here, one over here. This pole is what? South pole. This pole is nothing but your North pole. Fine. Now, when Earth because of its because of its revolution around the Sun, can come closer to the Sun or can move away from the Sun. It can come closer to the Sun and it can move away from the Sun. Fine. Now, because of tilting, you see the sun rays is going to what? Sun rays is going to fall at the equator or sun rays is directly overhead what we call as a Tropic of Capricorn. So at this point when sun is there, what is happening? Sun rays are directly coming towards where? Tropic of Capricorn as well as the vertical equator. But when Earth is at this position, you see sun rays is directly coming to which part? To the Tropic of Cancer part. That is okay there. Sun rays is directly coming to the Tropic of Cancer part. This part is tilted towards sun. This part is okay, not tilted towards sun. So what you see is okay. Earth is not like this. Earth is tilting like this. So this part is getting direct sunlight. That is okay there. Clear? So as a result, what you see is okay. Length of the day and night keeps on changing. Length of day and night keep on changing because of this tilting. Length of day and night keeps on changing because of this tilting. Clear? Now, when the sun is at this overhead, Tropic of Capricorn, when sun is overhead at Tropic of Capricorn, we'll see Tropic of Capricorn will have, or southern hemisphere will have more day and more length of day, and the northern hemisphere have what? More length of night, because sun is away from Tropic of Cancer. So that's why northern hemisphere will have more length of night and southern hemisphere will have nothing but okay, more length of day. Clear? So at 22nd of December, this day, we call it as a winter solstice. We call this as a winter solstice. Why? Because northern hemisphere faces longest night. Longest night is being faced at this date. Northern hemisphere faces longest night and shortest day. So when night will be longer, day will be shorter. This is being faced at the northern hemisphere. While the southern hemisphere will face what? Southern hemisphere will face longest day and shortest night. Longest day and shortest night. This is what you are observing as southern hemisphere. So when sun is overhead at Tropic of Cancer, we'll see northern hemisphere will have what? Northern hemisphere will have a longest night and shortest day, while southern hemisphere will have longest day and shortest night. This day is referred as what? This day is referred as a winter solstice. So remember, whatever nomenclature we are adopting is with respect to northern hemisphere. Why? Whatever nomenclature we are adopting is with respect to northern hemisphere. See, northern hemisphere on 2nd December, you see northern hemisphere is facing what? Facing longest night. When longest night, what will happen? Winter conditions. So that's why we are calling it which one? Winter solstice. Okay, we call it. So all this nomenclature we are adopting is with regard to northern hemisphere, not with regard to southern hemisphere, because in colonial period, geographical more discovery had happened from the northern side. That's why whatever nomenclature has been given from the is from the European perspective, from the northern hemisphere perspective, not from the southern hemisphere perspective. Fine. So this part you have to keep in mind with regard to 22nd December. When Earth reaches over here, this is called as what? This is called as 21st June period, where you see what? Where you see longest day and shortest night in northern hemisphere. In northern hemisphere, you're going to observe longest day and shortest night. And in southern hemisphere, you're going to observe what? Shortest day and longest night. So you're going to observe shortest day and longest night. Clear? So in northern hemisphere, longest day, shortest night. In southern hemisphere, shortest day, longest night. So that's why this day is referred as a summer solstice. Fine? Because of northern hemisphere is facing more summer. So longest days, shortest night. Fine? Now, when Earth is at this position, positions are referred as equinoxes. These positions are referred as what? These positions are referred as equinoxes. So this equinoxes will occur. Equinoxes means equal day and equal night. Equal day and equal night. Equinoxes means equal day and equal night in both southern hemisphere and northern hemisphere. So both northern hemisphere and southern hemisphere will observe equal day and equal night. Length of the day and night will be equal. That's why it is called as what? It is called as equinoxes. Okay, so equal length of day. Equal length of day and night. Equal length of night. So that's why this period is called as what? This period is called as equinoxes. Clear? This equinoxes is observed at 21st of March and at 23rd of September. So these equinoxes are observed at 21st of March and 23rd of September when the sunlight is, why it is observed? Because sunlight is directly over equator. Sunlight is directly over equator. That's why it is called as equinoxes. Fine. So when sunlight is exactly in the middle, all places will receive equal day and equal night. That is why these periods are called as what? These periods are called as equinoxes period. Fine. So on two type of equinoxes, okay, that you have, it is called as what? It is called as a spring equinox because it is occurring in the spring season. It is called as an autumn equinox because it is occurring in the autumn season. Clear? So that's why two equinoxes you're going to observe: spring equinox and autumn equinox. Fine. So this is how the earth revolves around whom? Earth revolves around the sun in a tilted axis, in a tilted manner. Clear? Any doubt regarding this one? When earth is...
Equinox will come on 21st March.
Yeah, 21st March and 23rd September. On 2 days you will see equinoxes when sun is directly over the equator. Fine? Fine, any doubt regarding this particular part? So that's why you see the maximum position of sun. So if this is the earth and these are your lines, you see the sun is directly overhead at which point? The sun is directly overhead at Tropic of Cancer. This is Tropic of Cancer, Equator and Tropic of Capricorn. Sun is directly at which position? Sun is at this position. Sun is at this position when? At 21st of June. Then you see sun moving towards what? Sun moving towards equator. Equator position. Here the sun is coming at which point? On 23rd of September. Then you see sun movement. Apparent movement is towards something but okay, Tropic of Capricorn. This happens when? At 22nd of December. Then we discuss again sun position coming back to where? To the equinoxes. When it is happening? On 21st of March. And then again it will reach to maximum this limit and again come back. Okay, so you can see the sun position keeps on, apparent sun position keeps on changing. Clear? So remember that sun is not moving. Sun is at fixed point, but what is moving is earth is moving. That's why the sun position keeps on nothing but again changing with respect to the earth. Okay, so either it is directly overhead at equator or it is directly overhead at Cancer or it is directly overhead at a Capricorn, depending upon nothing but the earth positions. Clear? Any doubt regarding this one? Fine? Any doubt? So you have two situations. One is called as a summer solstice, another is called as a winter solstice. In summer solstice, northern hemisphere will have longest day and shortest night. In winter solstice, northern hemisphere will have a shortest day and longest night. Fine. Now, when the earth will reach closer to the sun, when earth will reach away from the sun. Because we discussed earth is revolving in an elliptical orbit. So, you will see the Earth may reach closer to the Sun and Earth may reach away from the Sun. That is okay there. Clear? So generally you will see Earth coming closer to the Sun around 4th of January and generally moving away from the Sun on 4th of July. This is something that is okay there. So Earth coming closer to the Sun on 4th of January and Earth moving away from the Sun generally on what? On 4th of July.
The time period of 4th Jan, it will start to come out, it will be other.
No, it will be closest to the Sun on 4th of January and what you see is okay, it will be farthest from the Sun on 4th of July. Clear? So as we discussed, when Earth is closest to the Sun, what happens? It is gonna receive more amount of sunlight. Clear? So it will receive more amount of sunlight when it is closest to the Sun. That's why at this point when Earth is closest to the Sun, northern hemisphere is facing what? When it is closest to the Sun, northern hemisphere is facing what? Southern hemisphere is facing summer. Northern hemisphere is facing what? Northern hemisphere is facing nothing but okay, winter. So that's why winter are mild in northern hemisphere, while summers are excessively hot in what? Excessively hot in southern hemisphere, because we are closest to the Sun, we are receiving more amount of sunlight. Clear? So when we are receiving more amount of sunlight, winters are mild in the northern hemisphere, while the summers are okay what? Summers are excessively hot in case of southern hemisphere, because southern hemisphere is facing summer at this point of time, northern hemisphere is facing winter at this point of time. Clear? Any doubt regarding this particular thing? Now, when Earth will be away, then what will happen? When Earth will be away, then what will happen? Less amount of sunlight. When less amount of sunlight, then what will happen? You see, northern hemisphere is facing what? Summer at this point of time. So when northern hemisphere facing summer, what will happen? Again, summer are going to be mild, because you are not receiving much of what? Much of nothing but okay, sunlight. Clear? And southern hemisphere is facing what? Southern hemisphere is facing winter at this point of time. That's why you will see southern hemisphere will have excessively cold winter. Southern hemisphere will have excessively cold winter. Clear? So northern hemisphere is what? Northern hemisphere is having mild winter also, mild summer also. Southern hemisphere have got excessively hot winter or excessively hot summer also and excessively cold winter also. Why? Because Earth position is changing. Earth position is changing. Fine? Any doubt regarding this particular thing? That's why you see more density of population where mild conditions are there, or where extreme conditions are there. Mild conditions are there. So mild conditions you are finding where? In the northern hemisphere. That's why in northern hemisphere you will see more population living. China, India, you will see European region. You will see more population in these regions. Why? Because mild conditions are there. You will see what? Lesser population living in the southern hemisphere because of excessively hot conditions are there. Clear? So southern hemisphere also have excessively hot and excessively cold condition. Northern hemisphere have mild summer and mild winter because of Earth's position. Fine? Any doubt regarding this particular part? Now, let's say a question comes like this. which is going to be correct?
Is it revolution?
Is it revolution? Anyone else? Now, the reason why Earth experiences 6 months of day and 6 months of night is because of what? Is because of tilting of Earth. So how tilting is happening? So as we discussed, when the sun is overhead at what? Sun is overhead at Tropic of Cancer. You see, sunlight will reach what? Sunlight will reach to the South Pole. It will not reach to whom? It will not reach to the North Pole, because North Pole is away from the sun. Okay, North Pole is away from the sun. South Pole is towards the sun. Clear? So that's why you will see what? You will see nothing but okay. This region will receive sunlight. Now, when it is moving like this, South Pole will receive, okay, and North Pole will not receive. But when it will come to this particular side, what will happen? Now North Pole is tilted towards sun, so now North Pole will receive the sunlight. South Pole is not tilted towards sun, South Pole will not receive sunlight. When it comes again, North Pole is tilted towards sun, so it will receive sunlight, South Pole will not receive sunlight. So it is tilting of Earth on its axis that is causing what? That is causing 6 months of days and 6 months of night. Clear? Any doubt regarding this one? If Earth was not tilted, it was like this, then what will happen? Poles will also have nothing but okay, what? Poles will also have a regular day and night. Okay, they will not have 6 months of day and 6 months of night. Clear? It is because of tilting. Because if it is tilted towards the sun, till the time it is tilted towards sun, this region will receive nothing but okay, constant sunlight. But when it will reach here, what will happen? Now southern pole will receive the sunlight, northern pole will not receive the sunlight. Again, what will happen? Only the southern pole will receive the sunlight, northern pole will not receive the sunlight. So it is because of tilting of Earth, you will see what? The 6 months of days and 6 months of night is happening. Clear? Any doubt regarding this particular part?
The position is changing because of revolution.
Yeah, position is changing because of revolution. Clear? But revolution is causing change in season, summer season or winter season. It is not causing nothing but okay, 6 months of days or 6 months of night. Fine? With the revolution, what is happening? Day and night is caused due to what? Day and night is not caused due to revolution. Day and night is caused due to rotation. Clear? So if Earth was nothing but okay like this, then what will happen? Then it will rotate like this. So if this side is facing the sun, so what will happen? Daytime. This side is not facing the sun. Night time. Since Earth is like this, what is happening? You see, poles are facing now, okay, much of the sunlight. This pole is not facing much of the sunlight. So that's why this will have a 6 months of day. This will have a 6 months of night. As it will move towards this side. Clear? When this it will come this side, what will happen? Now this poles will have okay what? The sunlight. Other pole will not have a sunlight because it is away from the sun. Clear? So it is tilting of okay axis that is causing what? Causing the 6 months of days or 6 months of night. Fine, any doubt regarding this particular thing? Now, assume if Earth is not rotating, what will happen? If Earth is not rotating, what will happen? If Earth is not rotating, currently Earth is rotating on its axis. If Earth stops rotating, what will happen?
Either it will be complete day or complete night.
Yeah, one side will have always day, one side will have always night. So what will happen? This will become too hot and this will become what? Too cold. And as a result, what will happen? There will be okay what? There will be difficulty in what? Difficulty in sustaining life, because too hot condition, too cold condition, that is okay there. Since Earth is rotating, you see nothing but okay, the other part is getting the sunlight and other part is getting the sunlight, that is okay there. So what if Earth okay stops rotating? If such type of hypothetical questions are being asked, then you have to write that okay, the one part of the Earth is going to what? See continuous day and one part of the Earth is going to see continuous night, colder conditions are there. What if Earth's rotation speed doubles? Then what will happen? Currently it is rotating with certain speed. What if its rotation speed doubles?
Day and night, it will increase.
Day and night will increase.
Not increase, I mean get faster.
Get faster. So currently we are saying the Earth rotation, with Earth is rotating with a speed and it is taking how much time? 24 hours. But if rotation speed doubles, then what will happen? It will take how much time to rotate? Only 12 hours, because rotation speed is now doubled. So it will take only 12 hours to rotate. When 12 hours to rotate, what will happen? Day and night will become what? Shorter. Day and night will become shorter in nature. So if Earth's rotational speed double, then day and night becomes nothing but okay, what? Becomes shorter. What if Earth's revolution speed doubles?
Yeah.
What if the Earth's revolution speed doubles?
365 days will come now.
Yeah, instead of 365 days, you have okay, what? You have, let's say, 180 days only, 180 days or 182 days, around that. Okay, Earth is completing. What will happen then?
Seasons also will change.
Yeah, seasons will become much more shorter in nature. That is okay there. Clear? What if tilting is not there? If Earth do not tilt, then what will happen?
Only one portion of the earth will get that sunlight or
No, because rotation is happening.
Equal portion of sunlight.
Yeah, then you will have all, okay, what? All region experiencing what? Equal number of day and night. You will see equal number of day and night. All regions will receive nothing but okay, equal day and equal night. Equinoxes will be there. Clear? Because sun is tilted, that's why you see length of the day is changing or length of the night is changing. If okay, no tilting is there, then what will happen? You'll see every region will receive nothing but okay, what? Every region will receive same day and similar night. Okay, that is okay there. Clear? Any doubt? So such type of questions can come in the case of examination to test whether you understand what is rotation, what is revolution, what causes okay the 6 months of days or 6 months of night, or what causes the change in season, what causes the change in day and night. So that type of questions can come in the case of examinations. Fine, any doubt regarding this one? So this is all about what? This is all about the concept of equinoxes. Next. Now we are saying that sun apparent position is what? Sun apparent position is changing in this region. So as we discussed, at 21st June sun is reaching over here. At 23rd of September sun is over here. At 22nd December sun comes over here. Again 21st of March sun is over here. So what you see is these region, at these region, what you are finding, this particular region receives maximum amount of sunlight. This region is receiving what? Maximum amount of sunlight. This region is receiving maximum amount of sunlight because sun position is changing in this region only. Here, so that's why this region is receiving maximum amount of sunlight. That's why we call this as which type of zone? We call it as a torrid zone. Torrid zone. The maximum amount of sunlight is being received in this zone. That's why this zone is called as what? Torrid zone. Clear? Now, as we discussed this part, Arctic circle and Antarctic circle. So this is 66.5 degree north. This is 66.5 degrees south. We discussed this is 23.5 degree north. This is 23.5 degrees south. And this is your equator, that is 0 degree. Fine. So the reason this region will receive lesser amount of sunlight. So when sun is here, it will receive more, but when sun is here, it will receive less. So that's why this zone is receiving less amount of sunlight. That's why it is referred as what? Temperate zone. Temperate zone, that is okay there. So this two region is referred as what? This two region is referred as a temperate zone where moderate situations are going to be there. Here more amount of sunlight, hot condition, torrid zone. Here in between this 23.5 to 66.5, what will happen? Moderate situations are going to be there. That's why it is going to be called as a temperate zone. When sun is here, this part will receive more sunlight. When sun goes here, this part will receive lesser sunlight. When sun is here, this part will receive lesser sunlight. When sun is here, this part will have more sunlight. So that's why it is okay. What? It is a temperate zone. But beyond 66.5 degree till poles, this zone is referred as which zone? It is referred as a frigid zone or polar zone. So this experiences 6 months of day and 6 months of night, and that's why it is referred as what? It is referred as a frigid zone, or it is referred as the polar zone. So that's why you have three different classification: torrid zone, temperate zone, as well as frigid zone.
in temperate we have minimum sunlight.
Temperate you have moderate conditions, neither too hot nor too cold. Frigid you have minimum. That's why very cold.
In torrid we have
More amount of sunlight. Fine. So torrid zone, temperate zone, and frigid zone. You have 3 different type of zone. So 23 between Tropic of Cancer to Tropic of Capricorn, the zone is called as a torrid zone. Beyond Tropic of Cancer and Arctic Circle or Antarctic Circle, you have which one? You have temperate zone, and beyond this you have a frigid zone. Fine. Now, one thing that you have to keep in mind is, let's say if sunlight is taking this path, or sunlight is taking this path to reach to the Earth's surface, in which case you have more chances of Earth receiving heat. If sunlight is taking this path or sunlight is taking that path, in which case more heat will be received by the Earth's surface.
straightly.
Why? Why do you
Because
think?
the length is very short, sir, so the heat might be more. Its length is very much too long.
Fine. What you see is when this is what this you are taking, of course distance is less. So chances of what? Chances of reflection of sunlight or refraction of sunlight or absorption of sunlight is very less, because less distance it has to cover. But more distance if you have to cover, what will happen? Reflection, refraction, absorption, chances of sunlight becomes more. Clear? So that's why what will happen at this, if sunlight is slanting in nature, we say slant. Slant means what? It is not exactly overhead but slanting in nature. If sunlight is slanting in nature, then what will happen? You will see less amount of sunlight is going to be received by the earth. But if sunlight is okay, what? Overhead, directly in nature, directly overhead in nature, you will receive more amount of sunlight. You will receive more amount of sunlight. Clear? Any doubt regarding this one? So when we are saying the sun position is over here, when sun position is over here, that is Tropic of Cancer. So maximum amount of heat is going to be received by what? Tropic of Cancer. As this part will have which type of rays? Slanting rays only. When slanting rays, okay, poles will receive slanting rays means what? There will be more chances of what? Reflection, refraction and absorption. Why? Who does reflection? Who refract? Earth will reflect. It is atmosphere. You have an atmosphere, no? So atmosphere, what it does? Cloud will absorb the sunlight, or cloud may reflect the sunlight. Dust particles are there. They may absorb, they may reflect. Okay, that is okay there. So that's why you see more amount of reflection, refraction, absorption will happen if the light has to travel more distance. So here, when sun is over here, light has to travel more distance to reach to the polar region. That's why poles receive very less amount of sunlight. They receive very less amount of sunlight. That's why it is frigid in nature. We discussed temperate region. They still receives greater sunlight because slanting is less over in the temperate region. So slanting is less in temperate region. So they receives a bit better sunlight than the polar region. And this region is what? This region, that is Tropic of Cancer, receives maximum amount of sunlight. Clear? So rays becomes more slanting in nature as we move from where to where? From equator towards polar region. So rays, sun rays are directly overhead towards equator or Cancer and Capricorn. As we move away from this region, you see rays become slanting in nature. So as we discussed, slanting means more chances of reflection, refraction. That's why these regions receives lesser amount of sunlight, called as a frigid zone or temperate zone, while this region receives more amount of sunlight, called as a torrid zone. Fine. Now there is also a term that you have to keep in mind. One is called as a insolation and second is called as a albedo. There are two terms, insolation as well as albedo. What is insolation? What is insolation? It is proportion of sunlight that is going to be intercepted by the earth. Proportion of sunlight, in simple term, proportion of sunlight that is intercepted by the earth is called as solar insolation. It is referred as a solar insolation. Proportion of sunlight intercepted by the earth is called as what? Is called as a insolation. Clear? And what is albedo? It is amount of solar insolation. Solar insolation reflected by the earth's surface. By the earth's surface. Or not absorbed by the earth's surface. It is not absorbed by earth's surface. It is reflected. It is not absorbed by the earth's surface. So proportion of sunlight that is intercepted by the earth is called as a solar insolation. And what is albedo? Amount of solar insolation reflected by the earth's surface or not absorbed by the earth's surface. That is called as what? That is called as a that is called as a albedo. Fine.
The sunlight which enters to the surface is called insolation.
The sunlight which enters into Earth's atmosphere, that is okay, what we are going to call as a solar insolation. Fine. So what you see is, let's say this is the sun, then you have Mercury, then you have what? Venus, then you have Earth. Mercury, Venus, Earth. So when sun is okay radiating energy, these energy is received by Mercury also, this energy is received by Venus also, Earth also, Mars also, Jupiter, Saturn, all are receiving energy from where? All are receiving energy from the sun. So whatever the sun is radiating, only a part of this energy is what? Only a part of this energy is received by whom? Received by Earth. Other energy is being received by what? Other energy are being received by other planet. So amount of energy of the sun that is intercepted by the Earth is going to be called as what? Is going to be called as a solar insolation. Fine. Amount of energy that is intercepted by the Earth is called as a solar insolation. Clear? So let's say this is Earth's surface and this is okay what? This is Earth's atmosphere. So how much energy that is reaching till or intercepted by the Earth atmosphere, that is going to be called as what? That is going to be called as a solar insolation. Fine. Some of this energy will also reach towards what? Reach to the Earth's surface. Some will be absorbed by the Earth's surface, but some will be reflected by the Earth's surface. Why it will be reflected? You have buildings. Building reflects what? Certain light. Glass can reflect okay sunlight. Then you will see what? You will see nothing but okay the ice. Ice are there. Ice reflect what? Ice reflect the sunlight. So Earth has certain features which are going to reflect what? Which are going to reflect nothing but okay sunlight. Now nowadays okay to curb the heat, even okay what will happen? Even the roofs are painted with what? Roofs are painted with nothing but okay reflective, so that sunlight is not absorbed by the building, rather it is reflected, so that buildings are becoming cooler in nature. That is okay there. Clear? So those things okay is you are doing because Earth has what? Earth has a property to reflect things. Earth has a property to reflect, and how much light is being reflected, how much sunlight is being reflected by Earth's surface is referred as what? Is referred as a Earth's albedo. So how much Earth is reflecting is going to be called as what? Is going to be called as a Earth's albedo. Fine. So these two terms you have to keep in mind. One is solar insolation, another is called as a Earth's albedo. Clear? Now solar insolation. Now solar insolation is not constant. How much the Earth is receiving is not constant. It keeps on varying. How much energy the Earth is receiving, intercepting solar insolation, it is not constant. It keeps on varying. Why it keeps on varying? Why it keeps on varying?
Changing the atmosphere.
Climate change.
Climate change. Any other reason? How much energy the Earth is intercepting keeps on varying. Why the change in climate is happening?
Revolution.
Why the change in climate is happening? Right now you are saying change in climate is happening. Why the change in climate is happening? Revolution causes okay the change in season. Okay, so do you call it as a change in climate? The term climate change is used for what? Currently you are using the term climate change are happening. Why? What you are using the term climate change for? Because of greenhouse gases or global warming. Okay, so greenhouse gases are more absorbing, and that is why causing global warming and change in climate. That is okay happening. Clear? So solar insolation keeps on varying. Why it keeps on varying? The one reason is what? One reason is distance of Earth from Sun. We discussed just now, Earth come closer to the Sun and Earth move away from the Sun. On 4th of On 4th of January, Earth is closest to the Sun. On 4th of July, Earth is away from the Sun. So distance from the Sun, distance of the Earth from Sun keeps on changing. When it keeps on changing, what will happen? Amount of energy that you are going to receive is going to what? Going to vary. Clear? Any doubt regarding this one? So one reason is what? One reason is distance of Earth.
Distance means revolution.
Yeah, distance means revolution only. Revolution means you are coming closer to the Sun and you are moving away from the Sun. So that distance is changing, no? At this point, what is there? At this point, we are saying we are closest to what? We are closest to the Sun. Distance is less. That's why we are receiving what? More amount of sunlight. More amount of sunlight. That's why we are seeing what? That the summers are excessively hot over here and winters are mild over here. That is okay there. Clear? But what if we move over here? Then what will happen? Distance changes. So when distance changes, how much energy you are going to receive from the Sun also changes. So that's why you see this is not constant. This keeps on varying. Clear? The solar insolation keeps on varying because of distance from the Earth. Second, we discuss altitude. Altitude of Sun. This also will differentiate solar insolation. Altitude of Sun. Just now we discussed, if Sun is directly overhead, more energy you are going to receive. If Sun is in slanting manner, what will happen? Less energy you are going to receive. So altitude of Sun from Earth also decides what? Also decides something, but how much you are going to receive. Clear? Now the third thing, what can decide is solar. Sun is exhibiting what we call as a sunspot cycle. The Sun is exhibiting what? Sunspot cycle. Sun is exhibiting which cycle? Sunspot cycle. Clear? So what happens in sunspot? As we discussed, Sun is consisting of what? Sun is consisting of many zones: core, convective zone. We discuss radiative zone. We discuss photosphere, chromosphere, and corona. So those are Those are the layers of Sun that we have discussed. Now sometimes on photosphere a dark spot appears, and this dark spot are called as what? These dark spots are called as a sunspot. Okay. Sometimes on photosphere a dark spot appear, and these dark spots are referred as what? Sunspot. Clear? When Sun under sunspot cycle, you will see what? You will see the Sun is emitting less energy. Sun is going to emit less energy. When this dark spot is going to appear, at that time Sun is going to emit lesser energy. When this dark spot is not there, at that time Sun is going to what? Sun is going to have more energy. Sun is going to release more energy. Clear? So dark spot is cooler part. It is a cooler part as compared to other part of the Sun. So that's why Sun is going to emit lesser energy when this sunspot cycle are going to appear. Clear? Why the sunspot cycle appears? Because of changes in Sun's magnetic field. So changes in Sun's magnetic field, the sunspot cycles appear. Generally around 11-year cycles are there. They appears every 11 years. That's what is called as a sunspot cycle. Clear? So whenever the sunspot cycle are there, Sun is going to emit what? Sun is going to emit lesser amount of energy. When Sun is going to emit lesser amount of energy, what will happen? What will happen? The Earth will receive lesser amount of energy, or solar insolation will be varying. Clear? So that's why solar insolation, whatever the Earth is receiving or intercepting, is not constant. It keeps on varying. It keeps on varying. Why? Because of sunspot cycle, because of distance of Earth changing, because of altitude, whether sun rays are coming in a direct manner or in slanting manner. So that's why this keeps on changing. Clear? Any doubt regarding this particular part? So this is the reason why you see what? This is the reason why you see the atmospheric condition will also change, because we discussed that in geomorphology we discuss whatever is happening is due to what? Whatever happening in geomorphology or interior process is happening due to Earth's heat. We discuss climatology, whatever things are happening above the surface of Earth is happening due to what? Sun's heat. So if sun's heat keeps on changing, all your atmospheric processes are going to change. Wind will change, okay? You will see formation of what? Cyclones will change. Other phenomena will keeps on changing. Yeah. So because of what? Because of solar insolation variation, you will see phenomena, atmospheric phenomena are going to change. Fine, in and out regarding this particular part. It will also alter the heat of the earth, heat balance of the earth. Clear? So what is heat balance and heat budget? We'll start with that in the tomorrow's class. Fine, in and out regarding this particular part. So what we try to cover today is what? Concept of latitude, concept of longitude, how longitude is helping us to determine what? Time, how time zones are something that times are being calculated, meridians are being calculated, why India have chosen a standard meridian that is 82.5 degree, and why many countries have many time zones, because one time zones will not able to meet the need of entire population if their longitudinal extension is more. So that's why they have a mini time zone. Like we discussed, Russia has a 11 time zone, USA has around 5 time zones, India has 1 time zone that we have discussed. So that you have to keep in mind with regard to why countries are mini time zone. Then we discuss countries passing through what? Equator, Tropic of Cancer, Tropic of Capricorn, Prime Meridian, Arctic Circle, which Indian state are passing through what? Indian Standard Meridian, or which state is passing through Tropic of Cancer, or city is located near to the Tropic of Cancer. Those particular points, facts we have to keep in mind. Finally, we discuss concept of rotation, revolution, equinoxes, solstice, and concept of solar insolation and albedo. Fine, any doubt anyone is having? Thank you for today.